So hello everyone, welcome in this video tutorial on exception handling, which is defined as per Java. So you'll learn basically what is exception, what are the different types of exceptions can come in a Java program, what is the hierarchy of the classes of for exception, and how the exceptions can be handled in Java. So those things we'll learn in detail in this particular video. So whatever the contents we are going to discuss in this particular video is arranged in this way that first this PDF will be provided in front of you. In this PDF, the entire data of the exception related things are provided. So, and this PDF you will get as a note. After watching the video, you can download it from the description of this video. Next, there will be many programs. I shall explain each and everything for the exception handling, not only just by theory, but also the same thing will be provided in terms of the lab programs. That is, it will be executed in front of you, and the Java programs you will get to be explained in this video. So we can explain this, we can execute this Java programs in two ways. First, we can execute through this Eclipse editor. So by using this Eclipse editor, we can execute the Java programs and can display in front of you. Else, we can go through by using this online Java compiler, and we can execute these programs from here. So either of the ways we can choose, and we can explain it. So this is how this program and this video is designed for explaining the in all about the exception handling in Java. So it's not like a overview of exception handling in Java. If you watch this video, then keep in mind that you are going to learn almost each and everything of exception handling. So your entire concepts on exception handling will be cleared through this video itself. So what do you mean by exception? Let's start with these concepts. An exception is nothing but an abnormal situation, an abnormal condition that generates during the runtime of a Java program. So when a Java program is running during some sort of problems which happens in some specific conditions, what will happen? Java program will lose its normal flow and the program flow will be stopped. So exception this is what the exception is. Now it generates upon a certain condition. Suppose you are going to run a big program, and while running this big program, your computer's memory has been exhausted. It's over. You don't have any much free space. So what will happen? An exception will be generated, and that exception will stop the normal flow of your Java program. But you don't want to do that, right? We want to somehow manage the situation and manage the memory. So that comes to the picture of exception handling. So what is exception handling? Exception handling is nothing but when an abnormal situation in the runtime of a Java program happens, it occurs, we'll manage that and we'll try to keep the normal flow of the program. That's what's the objective of exception handling. So let me go through the video, the PDF right now. The exception handling in Java is one of the powerful mechanisms to handle the runtime errors. Keep this thing in mind always. Exception is the runtime error, not the static or compile time error. Yes, this is what the exception is. So what is exception is Java? In dictionary meaning, exceptions is any abnormal conditions that occurs in a program. In Java, we say the exception in general terms like which is not normal, that's exception, right? We say now there is a proverb that an exception is not an example. So what is example? The normal things which are happening is an example. Yes, for example, if a student comes to the college and if he comes to the school, if he attend the classes in good regularly, and if he submits the assignment, if he write the IA, then the students will become a topper. But suppose there are some exceptional students who doesn't attend the class, who doesn't write assignments in time, who doesn't write the internals, but they prepare somehow by their own and they can also be a topper. So that topper will be an exception. That's not a normal. So an exception in Java is what? An exception is an event that disrupts the normal flow of the program. Yes, something else that usually don't happen, and that has stopped disrupts the normal flow of a Java program. That will be known as the exception. So an exception, like each and everything in Java, is also an object. So when an exception is thrown, a Java virtual machine actually throws an object. That object you can catch and you can process, you can manage, all those things can be done with that object. with that exception, and this is known as the exception handling. So what is exception handling? Dealing with the exception object which will be thrown by the Java virtual machine. Yes, so exception handling is mechanism to handle the runtime errors. The runtime errors are the exceptions. So to handle the exceptions, and the mechanism which has been provided by Java itself is known as the exception handling. So what's the advantages of exception handling? If you handle the exceptions properly, then it will maintain the normal flow of your Java program. Yes, otherwise the exception will disrupt the normal flow of the application. Yes, that's why we need the exception handling. So for exception, like each and everything in Java, we have the predefined packages, correct? The predefined classes, and inside the classes we have the predefined methods, correct? So for exception also we have the hierarchy of Java classes. So there are many Java classes which is used for handling these exceptions. Which is the root class, that is which is the most base class of all classes in the exception hierarchy? The answer is java.lang package is there. Now, this is the default package. As we all know the basics of the Java, it is that there is a package known as the java.lang package. In this java.lang package, it is automatically imported to each and every Java program. Java.lang package is imported to each and every Java program, correct? So in this package, we have a class named as the throwable class. So this class is predefined and inbuilt in Java. In this throwable class, there are two classes which inherits this throwable class. Name of the classes are exception and error. Among that, exception class is the most important class in Java exception hierarchy. We'll see this hierarchy now. So look at this hierarchy. We have the throwable class, which is the root class of all the exception classes. Now we have the exception class and error class. So this error class has many other classes which has inherited this error class, like StackOverflowError, virtual machine error, out of memory error. So these these classes and their objects will be generated, and this is known as the checked exceptions, because these exception types are managed during the compile time. Yes, error class and its subclasses objects are thrown during the compile time only. So these are known as the checked exceptions. And the main type of the exceptions, the core of the Java exception is exception class. And its derived classes specify which specific type of the exception is being generated, and it deals with that. So exception class is inherited by IO exception. So IO exception class deals with the input-output exception types. Similarly, we have the SQL exception. So SQL exception also inherits exception class, and it defines particular things for the exceptions which will be generated due to the SQL programming. SQL stands for Standard Query Language, and it's a DBMS programming language. Similarly, we have another class which inherits exception class, that is class not found exception class. So this class will be throwing an exception if you create a class which is not found. If you run a particular object of a class, suppose, and the class is not created, so class not found exception will be thrown. Similarly, we have the runtime exception. It's a very important exception class. Runtime exception is also inherits the exception class, correct? In this, runtime exception also is inherited by many other classes, like arithmetic exception, which throws only arithmetic exception. An example is divided by 0. If you divide some value by 0, it will be infinite, right? So it will throw arithmetic exception. Next, we have the null pointer exception. A null pointer exception is telling that you are going to specify some object to some null values, and you are going to access that. Then it will throw null pointer exception. Similarly, we have the number format exception, index out of bound exception. This index out of bound exception is again inherited by two classes: array index out of bound exception and string index out of bound exception. So these are the specific type of the exceptions. Array index out of bound exception specifies that suppose you have an array with the size 5, but you are going to access the 10th location of the array. Then what will happen? It will throw an array index out of bound exception, because you are going to access some location of the array which is not available. So during runtime, it will throw array index out of bounds exception. So these are the exceptions which is thrown by the Java to let you know that what kind of problem is happening in this Java program while execution. So you can manage this exception also. You can deal with these exceptions also. And successfully you can maintain the flow of the Java program. So it will not stuck your Java program, it will not terminate the entire part of your Java program if you can deal with the exceptions properly. So there are mainly two types of the exceptions, checked and unchecked. And error is a condition as the error is considered as unchecked exception. However, according to Oracle, there are three types of the exceptions. This is the best and the most correct definition of exception only. That is, it is having three types of the exceptions. What are the three types of exceptions? First one is checked exception. What is checked exception? The checked exceptions are those classes that directly inherit the throwable class, except the runtime exception and error. Yes. For example, IO exception, SQL exception, etc. Yes, these are checked exception. These are the compile time exceptions. Yes, unchecked exceptions are those which happens during the runtime. For example, arithmetic exceptions, null pointer exceptions, array index out of bound exception, string index out of bound exception. These are the unchecked exceptions, and it cannot be checked during runtime. Sorry, compile time. It can be run only through runtime only. So these are what? This runtime exceptions. These are what? These are the unchecked exceptions. Correct? Yes, this cannot be checked. And others are the checked exceptions. And we have the error. Errors are like irrecoverable. Is once happens, it will stop. Some examples of errors are out of memory error, virtual machine error, assertion error, etc. See, out of memory error, virtual machine error. So these things are errors class derived exception. These are the errors actually. It cannot be dealt. So we'll now focus on the exceptions directly. We'll first show you that some scenarios, some cases, some case studies on Java exceptions. That is how Java exceptions can really happen. We'll see. The first scenario we'll give is that arithmetic exception type. As I told just a few minutes before that, if you divide a number by 0, it will be an infinite number, because any number cannot be divided by 0. So that will create an arithmetic exception. So integer a is equals to 50 by 0. This will what? This will generate arithmetic exception. Now we'll see about the null pointer exception in a scenario that when null pointer exception can happen. Suppose this string s you have defined is equals to null. Then this string s doesn't have any value, right? It just points to the null. But you are in the next line trying to get the length of the string. So this string is null. How can you get the length of it? It will throw the null pointer exception. Java JVM will throw null pointer exception. Similarly, a scenario where number format exception occurs. See, this number format exception is when you are going to trying to on a formatting which is going to be mismatched. That time it will throw number format exception. For example, this string s is given with the value abc, but you are going to change this string to integer by integer.parseInt method. Integer is the class and parseInt is the method which is defined inside the body of the predefined class integer. But one string cannot be parsed to the integer value, right? So it will throw number format exception. It will tell you that you are going to do something wrong. Similarly, we have the array index out of bound exception. See, here is a very widely used and very widely known exception actually. This is the very simple example of array index out of bound exception. You have created an array with the number of elements maximum is 5. But so we have in this array location A0, A1, A2, A3, A4, correct? Up to index 4 it can access the elements because it has the maximum size of 5. But you are going to access the 10th location, 10th index of the array and assign the value 50 on it. So it is not possible, definitely. It will throw array index out of bounds exception. So these are the some situations which actually generates the exceptions. These are the scenarios. These are the case studies of exceptions. I hope that these examples will let you know that what and when the exceptions may happen in Java. Correct. Now we'll see the keywords which are used for exception handling. Now we'll see what the keywords which deals with the exception handling in Java. So Java provides mainly 5 keywords. These 5 keywords are like everything in exception handling in Java. These 5 keywords are like everything. try, catch, finally, throw, and throws. See this, the difference is throw and throws is just a single S is put after throw. But these two things are completely different actually, having lots of different capacities. We'll explain it one by one with programs, all these things. So first we'll learn something theoretical, something regarding this keywords. So what is try? The try keyword is used to specify a block when we should paste an exception code. So suppose in some lines of your code, suppose you are going to return this kind of thing or this kind of thing. You think that the string the string object may be nullified already, but you are going to access the length of the string or similar kind of thing you are going to write in your code, and you are assuming that you are thinking from your experience that as a programmer you have gained lots of experience, just to imagine, and you understood that this particular lines of code may generate some sorts of exception. So you will put that lines of code inside a try block. Try block is like try, open the curly bracket and close the curly bracket. That's enough. So whatever you write inside these curly brackets will be known as the try block. Yes, that will be written inside the body of the try block. When you will put some code inside the try block, when you will imagine that or guess or assume that these lines of code may generate some exception. If it doesn't generate any exception, doesn't matter. But if it generates some exception, it can be easily handled using the try and catch block. I'll come to that thing later. With the programs also I'll come it to you and explain it to you. So the try keyword is used to specify a block where we should place an exception code. So it's not mandatory that having said that we should place an exception code, having said that we don't mean that definitely an exception should be generated from that lines of code. No. We are telling that we assume that an exception may generate from these lines of code. That's it. So it means that we can't use try block alone. Keep this thing in mind. The try block must be followed by either catch or finally. So it's not like we have the if else statement, right? But if can be written without else. But the same thing is not possible over here. For the try, it should supposed to write either catch or finally. You cannot write try block alone. Why? Definitely there is some significance. We'll just learn first catch and finally then I'll tell you that why this thing is there. That why try block must be followed by catch or finally. Okay, we'll learn about the catch block now. The catch block is the main place where we can handle the exception in Java. Catch block is also like a try block kind of thing, that is catch, then we provide the curly bracket, open and close. Yes, so try block is like this. Suppose you are writing something here. So you are writing try block, correct? So you are writing try block here. Now after try block, it is giving error because you are not given catch or finally. You have to give the catch. See this now. In the catch block, you must have to provide some exception class object. If you provide the exception class object, then it is not giving any compile time error. Have you understood now? So in the try block, you will put some code. That code may generate some exception. So you assume that integer a is equals to 50 by 0. It will give an exception. Now what exception it will give? Arithmetic exception it will give. As I explained. Why it will give arithmetic exception? Because it is divided by 0. A number cannot be divided by 0. So it will give an exception. So if this exception happens, then this exception will be, we are assuming that, okay, first let you make it clear that you are assuming that these lines of code will generate some exception. So you will put it inside the try block. Now if the exception generates, then only it will come to the catch block. And then in the catch block, you can do some lines of code to deal with this exception here. Yes, if it and if the try block doesn't generate the exception, then you don't need to care. Then don't bother. Now why to bother? Let me write and show it to you. Catch block, and we are writing, suppose this object also we are printing. Then this particular Java program will do what you know. It will check that the exception is generated over here or not. If the exception is generated in line number 8, then it will come to the catch block, and whatever you are writing over here, that will be printed. See here. Catch block. Okay, I'll provide a semicolon, then it will be clear to you. See, I've given some space, correct? Well, now it's larger in front of you. So if I execute this, you can see that this catch block is printed first. Correct? So this exception is basically generated. Now we are printing this exception by using this object E. So this object reference E will provide you the exception which has been generated. So what exception generated? That exception is generated is java.lang arithmetic exception. So as I have shown you over here, this arithmetic exception has been generated. This arithmetic exception object has been generated, which is there inside the runtime exception and which inherits the exception class. Yes, so here if you don't print this, then also it's fine. Then this divided by 0 has make the exception you can't understand, but it will still work. Yes, catch block. So you understood that without this catch or finally, if we cut this statement, it will give an error. See this? Syntax error, insert finally to complete block statement. It's asking to insert at least finally. Because this is how the Java code is written basically. Now we have written finally, well, it's working well. In finally also you can write down the same lines of code, right? System.out.println finally block. So as you can see that this finally block will be executed. See, this exception has generated, correct? And then finally block has been executed. So if you don't generate the exception, then what will happen? Suppose 50 is divided by 2, then there will be no exception, right? Still the finally block will be executed for sure. Finally block will be always executed. But the catch block, if you provide here, then the catch block will not execute if there is no exception. Keep this thing in mind. These things are very important concepts regarding exception handling. Okay, exception class, right, as I put last time. So I'll put exception here only. Okay, we can put other class name also. I'll show you one by one with many other programs why we are not putting this. Now see, this catch block is not executed because there is no exceptions coming from here. The catch block is not executed because there is no exception generated. If we generate the exception, then only it will come to the catch block. But in either condition, finally will be executed for sure. Although last time we put 2 over here and executed, catch has not executed, but finally has executed, right? But if we provided 0 over here, then definitely divided by 0 exception will be generated. Then catch block will be executed. Plus finally will be executed for any terms, for any time. So this catch block is executed and finally block is also executed. So now we'll go through the theory a bit. So the catch block cannot be written alone. It must be preceded by try block. If I remove this try block, catch block will throw an error. The Java compiler won't understand why you are putting catch and finally. So catch and finally is of no use without the try block. Yes, so this is the basic concept behind that try, catch and finally. So the finally block is used to execute the necessary code of the program. It is executed whether an exception is handled or not. Yes, now we have the throws and throw. The throw keyword is used to throw an exception. Suppose you yourself want to throw some exception for a certain condition. You can do these programs and you can understand that when to throw an exceptions, all these things when you are going to be a moderate level programmer. But for the time being, I'll show you with simplest examples that how throw can throw the exception, how you can throw your own created exception using the throw clause. Actually, it is very much important for the large and big real world Java projects. Then we'll go through the throws. The throws keywords is used for method only. A method can specify that this method which you have defined or the system has defined may generate this and this and this exceptions. Yes, so in a method signature we can specify that these exceptions can be thrown as a result of this method, so that the calling code part, the part of the code which is calling that most probable exception throwing methods should be placed inside the try block. Yes, so an exception, if a method throws some exceptions, it doesn't mean that it will throw the exception for sure. It throws. There is a huge probability that this method will throw some exception. Then we'll write down the method name. Suppose integer my method throws arithmetic exception as an example. Yes. Now when you call this my method from any part of the code, other part of the code, we have to place that part of the code inside the try block, because it may generate anyhow exceptions. I'll go through with all these things with the codes now. Now the theoretical part is over. Now we'll jump into the practical things. So learning the same thing throughout the practical programs. Now we'll first start with the try catch block. So we'll go through the try and catch block. Before I showed you the syntax of the try catch block, correct? So this is the try catch block signature which I show it to you. Yes, that is the try block and then catch block. This finally is mandatory. This finally is optional. If you remove finally, there will be no problem. This catch is also optional if you provide finally. If you provide finally here, this catch is then optional. But without catch, generally we don't write try, because catch is the specific place we can deal and handle the exception. Yes. So this is the syntax of Java try catch. So in case of finally, nothing is written over here, but in case of catch, we should supposed to write down the class name here. Class name, any hierarchy of the exception class name and their object reference. Here then we write down the object reference over here. Yes, class name and object reference. So what's the class name? We can give the exception class in a very secure way, because exception class is the root class of all the runtime exceptions. And here you can give any exception object reference. Generally we give E. For finally, as just before I showed you, for finally there is no bracket to be open after that. It's like write down finally and then open the curly bracket. That's the finally block. The Java catch block is used to handle the exception by declaring the type of exception with its parameter. So the type of the exception we are specifying here, that is, we are generally here, we are not giving any exception specification, that is the arithmetic exception or array index out of bound exception or any other specific kind of exception we are not providing. We are just telling that exception. So any exception can be dealt with that. But the most standard, the good approach to declare the generated type of exception. The particular class name in the hierarchy, if you use, then it will be a sign that you are a good programmer and you are dealing the things with a very nice way. I'll come with these things one by one. Let we see if we don't use, see this code will generate exception, correct? It is divided by 0. But you are not handling the exception. What will happen? The program is thrown the exception and it's cut out. See this. Divided by 0. Who's telling this? JVM is telling this. What kind of exception happens in thread main, in the main method? What kind of exception happens? Java.lang arithmetic exception. So this exception is generated by which class? Arithmetic exception class, which is the, as just before I showed in the PDF, this class is inherited the runtime exception class. That runtime exception class is inherited the exception class, and exception class has inherited the throwable class, which is in java.lang package. Anyhow, this divided by 0 exception is thrown by which class object? Arithmetic class, arithmetic exception object, correct? Yes, and which line? 6th line. So in 6th line this exception has been happened. Now so this is without try catch. We are not going to, in this particular example which is then in front of your screen, we are not going to do any sort of exception handling mechanism. Now we'll put the exception handling mechanism. We'll give the solution by exception handling. We'll write down the same lines. Of why I'm copying this thing and writing is that to save some time, so that the duration of the program becomes a little. Otherwise the video will be very large. So this try block is put now. This particular thing has been put within this try block. Correct? Now the catch also written. How we have written the catch now? Arithmetic. Last time I did some mistakes in writing the arithmetic. So arithmetic exception is the name of the class. So you can specify here the proper class name. If you are very sure that this will generate an arithmetic exception only, then only you can put the specific class name which is provided over here in this hierarchy. So yes, arithmetic exception. So this class object, this class you are specifying over there. Yes, and their object. Now you are printing this object. Then what will happen? See, exception will be definitely generated. Then this exception is handled. So we can print this exception and then rest of the code will be executed. Yes or no, that's the most important thing. If the rest of the code, this line, that's line number 15 is not executed, it means that exception handling is of no use. Because when the exception is handled in the last example, you have seen that the program stopped working. So here the program has not stopped working. Here the exception is handled over here and the rest of the program flow was maintained. Correct? So now we'll see that how this, see this in this program, I executed this, correct now? So this line has not been executed because exception is not handled. The program stopped its flow. The exception has stopped the flow of the Java program. But if we put there this exception handling code, then the Java program flow is not totally disrupted. That's why this line is being printed even after the exception is handled. Since rest of the code is printed, even though the exception is generated of the type divided by 0, the rest of the code, the next line is executed. I can print it here, then you can understand that this thing has been managed by catch. This exception is managed or handled by this catch. See this, managed by catch. Managed by catch. So this line is just displayed just for you. If you don't want to print, you don't print that. Don't print the object E. Doesn't matter. Still it is managed, right? You have successfully managed with the exception. That's why the remaining rest of the code is running. If you don't write, the question might come that if you don't write anything inside the catch, then what will happen? See, it's very simple thing. If you don't write anything inside the catch, nothing will be printed. But the important thing is that the exception is catched and handled. That's why the remaining code flow will be keep on going on. So your program is not completely disrupted. That's the important thing we have learned from here. Next we'll see that what if we provided here the rest of the code. So we'll just writing a single lines of code over here. So actually I just want to make your concept 100% clear. So why you are writing in line number 9 rest of the code? The question is that this rest of the code, I'll write down in try, so separate from this code and that code. So tell me that, assume this line of code will be printed in the output screen, yes or no? The answer is no, because whenever the exception is generated, the program flow on that block will be disrupted unless it is handled by catch block. So it will be coming from line number 8 directly to line number 12 and it will be handled over here. Yes, but then other lines of the code will be executed. But the try blocks, other lines of code will not execute. See this, rest of the code in try block, this line is not printed. Because here the exception is generated, so it has jumped to this line number 12. Yes, so if I print this, this will be executed for sure. This E will be displayed. Okay, but after generation of the exception, the other lines of the try block will never execute. It will be jumping to the catch. Now in the next example, we'll see that parent class exception can be used to handle this. Now we are not using arithmetic exception. Rather the parent class of arithmetic exception is what? Runtime exception. And its parent is exception class. Even we can specify that parent of this class. Parent and the parent of the class. And then also the exception can be handled. Yes, so you can use exception as a safe. If you don't know that which short of the exception may generate this try block, then you can just simply provide exception, because exception is the base class of all the runtime exceptions. So you will be safe. Yes, don't give wrong exception type. Yes, then it may not be able to handle the exception sometimes. I'll give that example also. Yes, now here we are just writing that can't divided by 0. So here in this particular example, what we are telling that, we are telling the user that why this exception is handled. So if you know that due to this reason that exception is handled, then only you can print this sort of things. Can't divided by 0 and rest of the code is printed. Yes? Understood? Now we see the next example. In this next example, what we can see this. there are two values has been taken, I and j. Okay, I'll copy this. See this, I and j has been taken outside, correct? We are dividing the data from I by j over here. Yes, and then resolving the exception in catch block in this way. That's also possible. It will give no errors. That is, I is divided by j plus 2. So j was 0, right? So it will be divided by 2. Then it will not give any error. See, 25 is shown over here. Because here exception is generated, that's why it has come to the catch block. Inside the catch block, we are doing some other lines of code, other stuff. We are trying to solve this. So now we divided by 2. So it is giving 25. And then rest of the code will be, this line will be executed for sure. Yes, now we'll see another example. That is, in the catch block, if we generate exception in the catch block, then what will happen? Because we always generate the exception in the try block, na? What if we generate the exception inside the catch block? No, it's not permitted. You can't generate exception in the catch block. Then definitely, if you assume that the catch block handles the exception. So if we generate the exception in the catch block, it will be safe. No, the program will disrupt. That's it. Because it should be in try block and in the catch block. See, the program is disrupted directly. Even this line is not executed. Rest of the code is not executed because exception has handled over here. When exception is handling over here, it can come to the catch block. But in the catch block, if you generate the exception, there is no other way. Come out of the program. Program will be disrupted. Yes. Now in this next example, we'll see that what if we use the wrong, just few minutes before I was just discussing now, what if you use the other and the wrong, class over here, wrong, hierarchy over here, and trying to handle the arithmetic exception using array index out of bound exception. Yes, it will actually works. If you're in the same hierarchy, it actually works. Oh, sorry, I'll change this line. See this, sometimes it works if it's in the same hierarchy, but it's not in the same hierarchy, right? This array index out of bound is not in the same hierarchy. Both are the subclass of runtime exception. Let me show you, otherwise you'll get confused. See, array index out of bound is the subclass of runtime exception through index out of bound exception, correct? But the exact exception generated over here is of the type of arithmetic exception. Yes, so arithmetic exceptions will be generated, so that can be only dealt with the runtime exception or exception class, not by array index out of bound exception, which is in the bottom down in the level of hierarchy. So it will generate the exception, it will come out of the program. So when the exception is generated over here, this catch block cannot deal with that. This catch block cannot deal with that. So what the solution? You can provide at the end the exception class hierarchy. Exception class can deal with that. Wait a minute. It will be very clear to you. I'm just writing the name of the class which is provided over here. And here we are having the exception. So exception class is handling this, and that is handling by array index out of bound exception. See, this error is coming up. Why? The objects are same. Array index AIE. So I'll give AIE over here. Okay, there is another mistake I made. Plus should be here. Okay, here also the same mistake I made. Let me correct it. See now, exception is generated by which class? This class is managing that. It is being handled by this particular catch block. So you can understand that for a single try block, we can define many catch blocks. That's what is a new thing you are learning, correct? And this exception will go to the correct exception class only. Array index out of bound exception is the subclass of index out of bound exception, correct? And it doesn't have the capacity to deal with the arithmetic exceptions. So exception is the higher class, higher root class of the type arithmetic exceptions that only can handle with that. Even the arithmetic exception can deal with that. Let me copy that arithmetic exception. that line that I'll show it to you, then it can happen with that. Even we can write down these lines of code also. Many catch statements we can give. See, arithmetic exception, we are giving it, correct? AE. Oh, sorry. Wait a minute. So now tell me, will it work? Which part will work now? Arithmetic exception, because this is the specific exception, correct? So Java virtual machine will find the most specific type of exception which has been matched. So for this is the arithmetic exception divided by 0. It is exactly matching with this catch statement. So this one will be executed. See this arithmetic exception. So this thing I have printed, right? That's being shown over here. So line number 16 to 19 is executed. Now this catch block is not executed because it's got the most specific exception type. So this catch block will not be executed. And then as it is handled properly, rest of the code will be printed because the other lines will be executed for sure. It will not disturb the program. It is handling the exception properly. But it will never execute this line. So you can understand that for a single catch, for a single try block, we can have multiple catch blocks. And the exception will go to only to that particular catch block which will handle it with the most specific exception class. If it is not having any specific exception class, then it will match definitely with the top of the hierarchy, that is with the exception class. It will work then. Exception will be printed. See, this exception is printed because we are printing here over. Yes, that's what is another thing I just showed you. That all exception classes cannot be handled in the catch statement. Only the specific exception class or the upper classes in hierarchy can be used for exception handling. Yes. Well, so 8 these examples we have gone through. This example, 10th example, now we'll go through now. So here we have a try-catch example, correct? So this example I'll show you using the online compiler. So in different things I'm trying to just show you so that you get also known with that. You should be a good Java programmer in future. So we have java.io class. This is a package java.io. And we are using file not found exception is defined over there. We are importing that thing because this package is not a default package, not like java.lang, which is a default package. And we are using the class printWriter, which is defined inside the java.io package. We are importing this also. Now we are writing public class try catch example 10. Correct? Now inside the public static void main, what you are writing? printWriter pw. So you are creating a reference of the object printWriter, of the class printWriter. Then in the try block, we are putting pw is equals to new printWriter jtp.txt. So you are trying to open this particular file, right? And this particular file may not be created. So in that case, it may throw exception. And then we are printing on that file saved. So the saved is being printed by using println method in this particular object, which is of the type printWriter, which opening this particular file. So if this file is not opening, then it may throw exception. So if it throw exception, it will go to the catch block. And the catch block is matching with the particular exception. Which exception? File not found exception. Yes, and we are printing the object specified over here. Then the rest of the code will be definitely executed because if the catch block successfully catch and handle the exception, then the rest of the lines will be executed. So file saved successfully will be executed for sure. Now we'll execute and see what happens. I think some problem in execution over here. So it will display over here the result, okay? I think due to some net problem or some other reasons, it is not displaying over here. I'll come back over here very soon. So let me just write down this part over here. See, it is giving errors, now these things. They're asked to, this is the best use of Eclipse is that this kind of ID will tell you that reason. See, they're telling to import this thing. If you import, double click there, it will automatically import. See this, it is understood why this error was coming. Now file not found exception, it cannot find, correct? So it will also tell to import that specific line. import this. Now it will be automatically imported. File not found exception. Now there is no compile time error provided over here, correct? Yes, this is extra. So now if you execute over here, let's see, file saved successfully is printed. Here also it should supposed to display actually file saved successfully. I think due to network issues and all, the compiler is not working well. Otherwise it will definitely give you the result. What? File saved successfully. While this file saved successfully is printed because it is not providing any error. Yes, this print writer is creating this particular text file and then it is printing over there saved. So jtp.text is opened and it is printing saved over there. So this try block has not generated any exception. So it has not come to this catch block only. So directly after creating this file and putting this saved, it is coming to the rest of the program as usual. So it's like a normal flow of the program. Line number 11, 12 has executed, then directly line number 18 has executed and it is printing file saved successfully without any exception. Yes. So we'll see regarding the multiple catch exceptions. I mean, how multiple catch blocks can be written. Just before I showed you, right, multiple catch block, even 3 catch block I showed you for a single try block. The same thing will run over here in a basic terminology using the theoretical analysis. So when there is a try block, that try, look at my cursor. When there is a try block is there, that try block will throw exception. If it generates exception, okay. If the try block has a code, lines of code which doesn't generate any exception, then it will come out and it will execute statement out of try catch block. It will come out of the catch block. It will not go to the catch block, as I'm telling continuously, because catch block can only comes into picture when there is an exception into the try block. Yes, so no exception means it will come out of all of the catch blocks and the remaining general flow of the work will be keep on going. Otherwise, it will find appropriate catch block to execute. It will find appropriate catch block to execute. Appropriate catch block means, just before I showed you that array index out of bound exception we used, then we used what? We used arithmetic exception and then we used the exception. So most proper exception class has been chosen. That was what? That was arithmetic exception, correct? So that particular catch block will be executed and then it will come out of the program. See here, the same program is given over here. Just let me show you again the same thing. I'll not invest much time on it because you know it already. No, I think there's some still problem is there in online compiler due to network only. So see this now. Okay, class body is not closed, just the main body is closed. Main method body is closed, not the class body. Okay, now we'll see the program. See, inside the try block, we are writing this particular array creation. We are creating a 5 element array. In the 5th element, we are giving 30 divided by 0. Then what will happen? See, 5 elements you have created means the index is from 0 to 4, correct? But in the out of bound, we are going from the array and providing 30 divided by 0. So which exception will be generated? If it generates arithmetic exception due to this, then this catch block will be executed. If it gives the error exception over here only, because we are going out of bound exception, array index out of bound, then this catch block will be executed. And anyhow, if you are not writing and if you are giving the wrong class name over here, class type for the exception over here and here, then it will go definitely in the exception hierarchy. But keep one thing in mind, this higher exception hierarchy should be kept at the end. Exception class you should not keep at the beginning. Okay, keep these things in mind. See, this arithmetic exception occurred actually. So when you are dividing this thing, that time the first exception is occurred here. Yes? Are you getting? So this catch block is executed. These things are not executed. So it will go to the out of the program immediately. I'll print it over here. Out of try catch. Out of try catch. Out of try catch blocks. Yes, that's being printed. arithmetic exception occurs. So that is the beauty of a Java program. That is, one catch block can have multiple, one try block can have multiple what? Catch blocks. And the appropriate catch blocks with the proper exception handling mechanism will be called. Now see here, I have divided by 2. So this part is not throwing arithmetic exception. But as we are going to access some index of the array which is not in the bound of this particular array, that is, it has the index from 0 to 5 minus 1, that is equals to 4, correct? But we are going to access A5. We can access A0, A1, A2, A3, A4, that's fine, no exception will be happening. But you are going to access A5, we want to put that thing to the A5. So we are going array index out of bounds, correct? So we are going array index out of bound, exception occurs. So this particular catch block is executed here. So this is an example of, for one particular try block, multiple catch blocks can be defined. See this, for this particular try block, these many catch blocks has been executed. Now we'll see the next programs, next examples. See, in this example will execute what? We are going to access the 10th element. It will execute into this particular catch block. That is, array index out of bound exception occurs will be printed. See, array index out of bound exception is occurred, and then the rest of the code will be executed as we are handling the exception properly. In the next example, we can see that we are dividing it and putting it over here, and then we are accessing this, correct? So it will execute what? It's a very important thing now. Now is a new thing you are learning. So I'll execute it and show it to you. See this, now it is executed. This will execute arithmetic exception, right? As you have seen before. Now after that, we are going to access this line also, correct? So it will display what? Array index out of bound exception, right? But will it display? I just showed the same thing before you, that in the try block, only a single exception can generate. Immediately it will go to the catch block. It will find the catch block for handling it. It will not, after an exception is handled in one line, it will not go to the next line inside the try block. It will jump to the, it will find the catch immediately. So whenever this arithmetic exception is handled, it has come to over here directly. It has not waited for another exception to occur. So this line is not traversed. This line is not even traversed. Even if you write down anything else, that line will not be printed. Correct? Now here, this line will be, suppose I'm writing not this, a very plain thing. Hello world. So would you think that this hello world will be printed after the exception is handled and generated in the line number 11? The thing is that an exception is generated means the try block will stop working. It will not go to the next line at all. It will jump for the particular catch statement. So this, after line number 11, 12 and 13 is ignored because line number 11 generated the exception. It has come to over here and this line has been executed. We go to another example. This is the null pointer exception, correct? It is generating the null pointer exception. See this. I'm just going to show you the different types of the exceptions also, because this is a complete video on exception handling. So here we are generating one particular exception. What type of exception it is? S.length we are printing. So it is an example of null pointer exception because this object is nullified. So there is no length of this object S, this string S. This string object S has no value, right? No area, no length, but you are going to access the length of it. So it will give you what? Null. It is a null pointer. Nah. So let me execute that. So this line is generated the exception, but this type of exception is not handled over here. In these two lines, you are going to access the arithmetic exception. And then this catch block is used for handling the arithmetic exception, and this catch block is used for handling the array index out of bound exception. So as this exception is not matched in here, it will go to the parent class exception. So exception is the parent class of all the exceptions, so it will come to this catch block, and that's why it is printing parent exception occurs. If you print the object over here E, then you can see that it will give you null pointer exception only. Null pointer exception. See this. It is generated null pointer exception. So if you provide a class of null pointer exception, that will be definitely executed. If you create an exception of type null pointer exception, then that will be executed for sure. Then it will not go to the exception because it will get the proper type of the exception type. Now I'll write here this thing. Oh my god, what I'm doing. Hold a minute. Null pointer exception is displaying now. Say this null pointer exception is being printed. This line is being executed. So this catch block is handling that. This catch block is now not handled because it has received the catch block with the proper type of exception that is being generated, and rest of the code will be executed because it has been properly handled. Now we'll go through with the multiple catch block next example. So here tell me which line will be executed. Yes, which line will be executed here? Task 1, task 2 or task 3? It's another new kind of thing. That's why I'm printing it again to you. See this here. So what you are doing it, okay, in this code only I'll execute. So here it's working properly, right? It is working properly and null pointer exception is got correct. So in this code you are showing that in this PDF, this program and this program, I'm just altering it. I just want to show you that it should be into the hierarchy. From the top to bottom, it should supposed to come. Exception class is the top, right? So this catch block you cannot put at the top. At the very top, you cannot put. You have to put this exception into bottom of the hierarchy. Otherwise, it will give a compile time error. See this. They're telling that why you are putting this. What is there? Why you are putting this exception at the top? Because it's the top of the hierarchy, right? You can put it only at the bottom. That's why the error is coming. That's what the compiler is telling. Exception in thread main unresolved compilation problem. It is not run only. The reason is that unreachable catch block for arithmetic exception. It is already handled by the catch block for exception. So exception has already handled. Similar for all, it will give in the same reason. It has already been handled by the catch block for exception, because catch block is the this exception is the root class in the hierarchy of exception classes. It's like arithmetic exception is a derived class of exception. Array index out of bound exception is also derived from the exception classes. Null pointer exception also similarly derived from the exception class and its classes. So it will give you what? And error. It can't justify this thing. So you have to put always the higher ups into the bottom. So this higher into the inheritance layer, inheritance hierarchy in the exception class should be given at the bottom. Then only it can execute. Now we'll see about the nested try blocks. So like the nested classes, we can nest the try blocks in Java. See this? This is the try block. Statements are there. Inside there is another try block. Now if this statement 3 and statement 4 gives any sort of exceptions, then it will go to this catch block. Yes, otherwise it will go to this specific try catch block. And statement 5 and statement 6, if they give any sort of the exception, then it will go to this particular catch block. And if at the top in the statement 1 and statement 2 any sort of the exception happens, then it will go to this particular catch block. Well, we'll see that. We'll see with examples. So we have that outer and inner try block. So give a bit of more focus here, because it's a completely new concept to you, but it's a simple concept. You understood the thing till now, that's sufficient. Whatever you understood that thing till now, then you can understand this thing also very easily. It will not be a big deal for you. See this now. I'll put this try in the left so that you can understand easily. Oh my god, what I did. So this is the try block. I'll put it in the bottom. This is the, okay, no, not this. This is the outer try block, correct? You have to understand now. This is the inner try block. This is the inner try block. This is the catch block for the inner try block. Now inner try block 2. Yes, this is the inner try block 2. Here we have this particular try and catch statements. Yes, are you clear? Now here it is closed. This is closing this try and catch block ladder for that. Now the catch block of the outer try block is here. Yes, so this is the outer try block starts over here, and inside there is an inner try block. If any error happens over here dividing by 0, then it will catch to this particular catch block. Yes, then again we have another inner try block. If any problem happens over here, it's happening, correct? This will give arithmetic exception and it will give array index out of bound exception. So this line will be printed. Yes, and then this other statements will be printed here. And then if any exception happens over in this try block, if you write down anything inside this try block, then this catch statement will be executed. So it will be in the hierarchy of this try catch block. So it's going to be divided by 0. So which one executed? Going to be divided by 0. Line number 13 is executed. Here it got the exception. So it is being handled by this particular catch block. So it is dividing by 0, it's displaying. After that, it has gone to the next try block. Here it is giving the exception, correct? Because we are going to access 5th point, but the maximum index is 0 to 4. We are accessing the index 5. It will give an error. Exception. What exception it will give? Array index out of bound exception. So it will print over here, array index out of bound exception. Yes, in the exception number 5. Then other statements will be executed here, because it has handled the exception successfully, and then it will come to the normal flow, correct? Yes, other statements will be printed, then it will come to the normal flow, because this exception cannot be executed, because there is no exception happens into the try block. If you do something right over here and exception happens, then that catch block will be executed. If you create any exception over here. In this way, try blocks can be easily managed. Like the if else ladder we have, or we have classes and inner classes, we have try catch block ladders in this way. Yes, so similarly we can see over here that there is a try statement over here, outer main try, then inner try block is there, inside there is another try. Here the exception is handling. So this is the arithmetic exception. No, this is what array index out of bound exception, correct? Here it is handling the arithmetic exception. It will not go over here, correct? It will not touch over here. It will not touch over here. It will go over here and handle array index out of bound exception. Yes, are you clear? Then exception file will be printed. Then if anything is there regarding this exception, then this will be printed to you. Got it? Yes, outer main try block. This particular catch will only deal with the entire matters. In this particular example, that's what being shown over here. I'm not executing this program again, because it's the same program only. Like the last program, we have the same content over here. So we'll go to the Java finally block. It's easy and fun. Finally block. It's very easy actually. Finally block will be a particular block in try catch finally ladder which will not execute. That's the beauty of finally. So one catch block may execute or may not execute, but a finally block will be executed even if there is no exceptions. Yes, so why to use this finally block? So clean up code sometimes you write. Sometimes you write a big project, suppose many try blocks are there. So on that try block, if you create some object and do some particular operation and we expect that some exception may happen. Suppose the exception has happened or not is a different thing, but we have to clean that objects and some other manipulations. So this cleanup thing can be done in the finally block, because finally block will be executed for sure. Yes, we'll see this particular code of the finally. I showed you before some lines of code definitely. So I'll show you another lines of code regarding with respect to finally. So write down this, yes, copy it, and these things are not required actually. I'm simply maintaining. So I'll write it here. correct? So this try block is dividing 25 by 5. So we are assuming that it may generate some exception as we have put inside the try, but it will not execute, it will not generate any exception. Rather, it will print the value of data is equals to 5, correct? Then this catch block won't be executed because there is no exception happened. So this catch won't be executed. But this finally will be executed for sure. Whether there is an exception, yes or no, this finally will be executed for sure. See this 5 is printed from this data. This data is having the value 5, so 5 is printed first. Then we have printed over, finally will be printed for sure. The finally block is always executed. Then rest of the code anyhow will be executed. There is no exceptions. Yes. So now if it is generating error means then what will happen? Then this catch block will also execute at the same time. Then this catch block will be executed if the exception is happened. Along with that, what will happen? This finally will be executed for sure. But here we are using null pointer exception, na? So null pointer exception can't deal with the arithmetic exception type. So it is directly coming to the finally only. Finally is executed anyhow. But this rest of the code is not executed. Line number 17 is not executed, see? Because the exception is not properly handled. So we don't need null pointer exception. What we need? Arithmetic exception, correct? So in the next line, I think that same thing has been done. Yes. So we have used the arithmetic exception here. Then catch will be executed for sure, correct? And we can print this arithmetic exception to say that in this catch we are here. So in this catch we are here. If we execute now, this catch will execute and finally will also execute. That's the best thing about the finally. See, this catch is executed and it is printing that divided by 0 exception has happened, and this line is printed. So here it is printing this line, and then finally is definitely executed. So whether there is some errors, whether there is some exceptions or not, finally will be executed for sure. At the same time, as the exception is properly handled, it will go to the other lines of the code also. The rest of the code is also printed here in this time. Last time it was not printed, right? So this is all about the finally clause, finally block and its usage. Now we'll go to the throw exception, the fourth keyword. So the 3 keywords we have learned properly with all examples. The first example was of try, then try catch, and then we learned about the finally also. Now we are going to learn about the Java throw exception keyword. So in Java exception allow us to write good quality code where the errors are checked at the compile time instead of runtime. And we can create custom exceptions, making the code recovery and debugging easier. So throw exception, actually we generate our own exception, we customize the exceptions. Yes. So explicitly we throw an exception. Explicitly by we ourselves, not by the JVM. We tell JVM to send an exception, to throw an exception. So we specify the exception object which is to be thrown. Yes. Because we just sometimes in a particular thing, when you write some particular job, when you do some particular job through some coding, we want to tell that this particular thing has happened. We want to generate some message in a runtime, in a particular time, when a particular condition is met into the runtime. So that time the throw is the only keyword we have to deal with that. We can throw the checked exception also and unchecked exception also. Yes. Why throw is used? Always keep one term in your mind, to throw the custom user defined exceptions. Yes. We can also define our own set of conditions and throw an exception explicitly using the throw keyword. Our own set of conditions. Suppose the condition is if you generate the number of student more than 60 for a particular branch, then the exception should be generated. Or suppose a student has come and he has taken the admission, but his age, when entering the age through your Java program, you see that the age is less than 18. So he should not supposed to be admitted into the college because his age is less than 18. So if a student's age is less than 18, throw an exception. So that thing cannot be done by the JVM, right? JVM doesn't know that for college admission, what's the age limit, but you know, and you are writing your own application. So that time you can specify that if the student age is less than 18, throw an exception, as simple as that. Yes. So this is the syntax of throw. Throw new. So we are creating an object actually using the new. An exception class, which particular class from the hierarchy of the exception you are using, that you can specify, and then the message you can print. An example is this: throw new IO exception, sorry, device error. Suppose your pen drive you are going to access, And suppose 2 or 3 applications has, you made the rule, that condition that your pen drive should be accessed only by 10 people at a time, not more than that, because you are worried about the health of your pen drive. Yes, so suppose whenever that 11th person is going to access your pen drive through your Java application, you just don't want to allow them. So you have provided the condition, if number of access is greater than 10, then within the if block you are writing throw new IO exception, sorry, device error. So this is your customized, your own exception you are throwing for the sake of your own pen drive, because Java doesn't stop you to access not even 10 people, 11 and 20th people or 100 people to access your pen drive. You want to worry about your pen drive's health, so you are writing this. So we'll go through now with the examples. The most important thing, you should supposed to know each and everything through examples. So here there is a method. The method is, name of the method is validate, and it's taking an argument of integer type. That is the age. If the age is less than 18, then you are throwing your own customized exception. What type of exception? Arithmetic exception. Person is not eligible to vote. So voting system you have defined, okay? Suppose the government has given you the project of voting. So how will manage with that? You are managed in this way. Yes, so entire thing you are writing in this way. So this is the public static method. So it can be called, this validate method can be called without creating an object of the class. Yes, and it should be having a value of integer type passed inside this argument. That's what you are doing from the public static void main. We are calling the validate method without creating an object of the class exceptions in Java. Exceptions in Java is the name of the class, right? We are not creating an object of the class. We are calling it directly validate, and you are passing the value 13. So when you are passing the value 13, it will come into the value and it will check this condition. If age is less than 18, so 13 is less than 18, correct? 13 is less than 18, so it will throw new arithmetic exception. What exception will throw? Person is not eligible to vote. Then what will happen? See this exception will be thrown. This is the output. This is the exception is displaying. What exception? Exception is thread main in this particular exception class is also displaying. Arithmetic exception it is, because you created this object of the class arithmetic exception just now, and you are printing that person is not eligible to vote. This message is being displayed over here. Yes, so this object of arithmetic exception class is generated with this message. Actually this arithmetic exception class provides the constructor with a string value, so that will generate the arithmetic exception class object with this particular string value. That's what being displayed as you are calling this, and this condition is met. We'll go through with the other programs, okay? Otherwise you may have some confusions. So now we'll generate this particular lines of code, and it's very easy code to be understood. So public static void method, the name of the method is what? Method, correct? And it throws what? File not found exception, which is available in java.io class. File not found exception. And what you are doing basically, you are going to access a file using the file reader class. This class is also available in java.io. Sorry, file reader is available in java.io. Yes. Not, I'm telling about the file not found. So here it is interrelated. This file reader file is creating a file object. Name of the file object is file, and it is creating a new file reader object, correct? And it is opening this particular file abc.txt, which is in my desktop. Yes, this is my desktop PC name. This is the URL for that abc.txt. Now buffer reader is another class which is available in java.io for reading from the file. File input object is created, new buffer reader is equals to file. These are Java IO operations, okay? If you don't understand, ignore that. Just to try to imagine that file input is a object we are creating, and then we are throwing a new file not found exception. Yes, so this method is throwing file not found exception, and we are telling into the method heading also that it throws this particular exception. So if a method throws, see, we are now going to the next, actually we are not only learning throw keyword, we are also learning the throws keyword. So if a method throw a particular exception and also specify that this type of exception may be generated by this particular method, then while calling this method you should supposed to put it inside the try block. You should always put inside what? The try block, and then you can catch this particular method here. Yes, you can put into the try block, and when this file not found exception will be generated, definitely, because you are throwing explicitly, this will be 100% generated each time because you are throwing explicitly. Even if the file is available abc.txt, then also it will be thrown because you are throwing it explicitly. Then we can use this object and print the stack trace when it happened. It can print it, and also you can print the object also. We have not done it. We can do it here. In catch block, and we can print this object E. Yes, and the stack tree also. So definitely when you are calling this method in line number 13, it will generate an exception of file not found exception. So it will come to this catch and it is matched with the file not found exception. So this catch can handle the exception properly. Then it will go to where? It will go to the in catch block E. And in catch block it will be printed in the output screen, and this object's name will be displayed. Then this objects and this is a system defined method, okay, to print the stack trace of this particular exception, and as the exception is properly handled, it will print rest of the code also. Let's see, let's execute and see this. See this now. In catch, see users desktop.abc.c text. The system cannot find the path specified. Yes, so this particular thing is being printed. The system cannot find the path specified. Rest of the code is being printed also. There is the stack is also printed now. Native method. Yes. This is the unknown source. That's why it is giving all these things here. We'll not print the stack. We'll just print the object. That's it. See this. Just a single line of code it becomes now. Sorry, just a single line of output it has become now. In catch, file not found exception. This exception we are generating only, na? Java.io file not found exception. Yes, the system cannot find the path specified. Why it is displaying? Because you have explicitly thrown this particular exception. Correct? Yes. So that's how you use the throw and throws. See, this file is actually not available in my desktop. abc.txt. It has been removed. Anyhow, it is displaying the exception. Yes, if this file is available over there, then if you don't throw this, then it will not execute. This exception will not come up. So I hope that you have understood the basic of throw and throws. Throws is used only in the method signature. Throws is used only in the method signature to display what? To tell that this method may throw some exception. So when you are calling the method, put into the try block. Definitely you have to put inside the try block. Never skip the try block if the method is displaying some sort of the, if the method in signature has throws. So the method signature has the throws file not found exception, right? So it's definitely, it's most probable to throw some so on that case, you should supposed to put it inside the try block. So you are unhandled. So add throws declaration surround with try catch. So this is the standard way. So Java IDE Eclipse is telling this thing that you put it inside the try block. So definitely whenever a particular method is displaying with its signature that it throws some exception, you should supposed to put that method inside the try block while calling it. Yes, now we'll see the next example, throwing the user defined exception. Now we'll create our own exception class, and we are coming to the next level actually, and then we are calling it. Now see, I have to maintain the class name here. So this class name I'll maintain, that's it. Okay, exceptions in Java. So what happens here, guys? User defined exception is a class which you have defined. Yes, you have written our own class, user defined exception. This class should extend the exception class. If it inherit the exception class, it means that it is now an exception class. Our class user defined exception is a class which is solely created for the exception making. And user defined exception is also having a string argument. So this string argument will be the error message, that's the exception message, like divided by 0, null pointer exception, and all the things which you are printing. In the last example, what you put? No, it's last example you have not put. So this is the error message which you are going to print. So while creation an object of the user defined exception, this constructor will be called, correct, with this particular error exception message. So this exception message will call inside this constructor. We are calling super str, right? We are passing this argument by calling the super. So super will call what? Super will call, because we are calling from the constructor, super will call the super class constructor, that is exception class constructor with the str as a error message. So it is now a fully fledgedly defined for a exception. User defined exception, if you create an object of this class with a single argument passed, initialize it, then it will be an exception class with that particular exception message. Now you are creating our own class. This is a public class exceptions in Java. It's a plain class. It's not extends exception. It's like any other class. Public static void main. Inside the try block, we are throwing an exception. What exception we are throwing now? See, not arithmetic exception, null pointer exception, not array index out of bound exceptions. These are the system defined exceptions, right? Now we are coming to the next level. Actually, you have customized our own class for exception. Just the next level we have achieved now. We are creating our own class exception. See, user defined exception. This is your own class. Now this is not the like the arithmetic exception, null pointer exception, array index out of bound exception. Those are the exception classes which has been defined by the Java, built-in Java classes. This is your own class, user defined exception, and you are putting this particular message that when this exception will generate, it will print out this message like divided by 0 for arithmetic exception. This is user defined exception. Yes, so definitely it will throw. Now this try block will definitely throw exception, correct? Because we are throwing it. We are throwing forcefully, explicitly. So you are throwing this exception. So the catch block will come definitely. So in catch block, you see, you are not writing exception or arithmetic exception or array index out of bound exception or null pointer exception. Rather, we are writing your own class name and your class name reference here, because your class has become an exception. Your class has become an exception class only, not a ordinary class. So now we are printing caught the exception. Then what exception? We are printing the get. We have to call the get message class. Get message is a method which is defined inside the exception class. So you can have the access to get message method because you have extended, that is, you have inherited the exception class into your user defined exception class. So this get message will give you this message. It will retrieve this message from the exception and it will print this is user defined exception. So let's run this. Caught the exception. This is user defined exception. So it is successfully generating the exception over here of my own type, user defined exception class. Then it is coming to this particular catch statement. It is printing caught the exception and getting the message from the exception object. It's an object, right? New we are creating. So this is user defined exception. So it is printing this is user defined exception. So you have come to the next level. Actually, you have learned that how to throw the exceptions also. Now again we are coming to the throws keyword. Now you know already about the throws keyword because one program I had shown in the method in the last program with the throws keyword. So now formally I'll tell you that one thing, that a throw keyword gives an information to the programmer that there may occur an exception. So it is better for the programmer to provide the exception handling code so that the normal flow of the program can be maintained. That's it. So this is the Java throws clause. It's used in the method only, method signature. So in method signature, you just write down a new line code after the method signature throws this type of the exception. That's it. Yes. Now the question is, which exception should be declared? Only check type exception, because only we can deal with the check type exceptions our own. Unchecked exceptions happens into the runtime now. So it's, we can correct our code, right? Yes. Yes, so error beyond our control. For example, we are unable, to do anything, so we cannot do with this errors and all. So advantage of Java throw keyword is that it can throw a particular exception and you can deal with that later easily. So that's the best thing about the throws keyword. Let me just show you this example. Let me give this example to you. Is it okay? No compiler, no syntax error, right? Let's see that it's working or not, then I'll explain to you. Yes, no syntax error. So see this, now we have created a class exceptions in Java, the same class name. Here we have a method aim which throws IO exception. So you are telling that whenever you call the method aim may generate an IO exception. So you are throwing also the exception here. What exception? New IO exception, device error. You're just simply printing this error message, okay? Actually, there is no device error. We just want to show you that how this IO exception throws clause can works for. Throws IO exception can works for. It is throwing what? New IO exception and device error. Then in the void n, it also throws IO exception. Here it is calling m. So as it is calling m, see now here it is not telling that you should put it inside the try block. Last program we saw that the Java compiler was telling, IDE Eclipse was telling to put it inside the try catch block because you are calling a method which throws some exception. But here m method throws an exception, but we are not putting it inside the try catch block. Why? And why it is permitted? Because this method also throws the same exception. This method also throws the exception, IO exception. So no need to put this m into the try catch block. Now from the void p method, we are again calling the n method now. This n method is being called from the p method, but void p method is not specified with the throws clause, correct? Na? It doesn't throws any exception. So throws is not provided over here. So n must be put inside that is the calling of the method n should be put inside the try catch block. Otherwise it will give an error. Compile time error only. That will not allow to write such code. Now we are going to the catch exception e system.out.println exception handled. Yes, so n will be called from here. When we'll call the n, it will be coming to this exception, correct? Na? This exception handling mechanism. Now we'll go to the main method where we'll execute the program actually. We have created the object of the class obj. We have created the object of the class obj and we have created new exceptions in Java. So we have created the object, right? Successfully. Now this object is used for calling the method p. See? P method is called. Yes, so if you have some visibility related issues, then let me make it clear to you. Let me make it clear. Yes, let the try goes there. See this, we are calling the p method. Yes, then p method will call n method. It's mandatory to put it inside the try because n throws IO exception and p is not throwing IO exception. So p is a normal method and calling a method which throws exceptions, correct? So it should be calling the method n should be put inside the try block. So it will call instead method m, correct? M method will throw new IO exception device error. So it generally, so in turns, this line of code will generate IO exception with the message device error. So exception handle will be printed over here. Yes, exception will be generated and it will be printed over here, exception handled. Got it? And then it will print normal flow. So exception handle is printed and then normal flow is printed. If you want to print this particular exception type, then you have to print this object E. So you have to print this object E, then you will get it the exception, that is IO exception, and the device error as a message also. See this now. Exception handle, java.io exception and device error. It's displaying, and a normal flow. Normal flow will be definitely there because the exception is successfully handled. So all the next lines will be executed. The program will not disrupt. That's why you're learning exception handling, right? So that the program flow doesn't disrupt. Yes. So the rule is that if you are calling a method that declares an exception, we must either have caught or declare that exception. Yes. Using try catch block, we'll see that how to handle exception using try catch block. So it's a very simple thing actually. Okay, I'll explain it. Well, if you've learned the other programs now, so this program will be very easy for you to understand. Class test throws. Okay. There are two classes, so I have to copy the entire program. See this now. In this program, let's start from the public static void main. We are creating an object of the class m. Okay, the name of the object is m only, small m. And m dot method, we are calling the method of the class m. Correct. Now this method throwing the exception IO exception. Correct. Yes. So it should be put inside the try block that we have done successfully. So no compile time error. Yes, no compile time error. It is displaying. So it is going to the catch block. Now it is printing exception. It is supposed to print exception handled. And then the normal flow will be provided. Exception handled and normal flow will be provided. If you want to print this IO exception and device error and all these things, then you can go and print the object E. See this? Exception handled, and then is printing this exception as well as the error message. Yes. So these are the similar thing with some, they are telling that if you are not throwing error, then what will happen? Then definitely the simple thing is that the catch will not be executed. As simple as that. Device operation performed will be called and normal flow will be maintained, because there is no, although it throws IO exception, that is most probably it will throw IO exception void method, but it's not throwing the IO exception, right? So device operation performed will be displayed and then normal flow will be maintained. This catch block will not touch because this line has not generated any exception. As simple as that. And if the exception occurs, then what happens? Just before I showed you. Yes. So what is the difference? What are the differences between throw and throws clause in Java? We'll go through with this particular table. So throw keyword is used to throw an exception explicitly in the code. Yes, it can be used inside the function or block of code. But throws keyword is used in a method signature to declare an exception which might be thrown by the function while the execution of the code. Now the type of the exception using the throw keyword, we can only propagate unchecked exception. That is, the checked exception cannot be propagated using throw only. Using throws, we can declare both checked and unchecked exception. However, the throw keyword cannot be used to propagate checked exceptions only. The syntax is that throw is the keyword we use for throwing the exception. Throws is the keyword which is used for telling that a particular method may throw, most probably throw an exception, but not mandatory that that method with the throws keyword will definitely throw an exception. But throw keyword will definitely throw an exception. Throw is used within the method. Throws is used with the method signature. And the internal implementation, we are allowed to throw only one exception at a time. We cannot throw multiple exceptions. As you've seen before, that if you throw two exceptions one by one, only the first exception will be thrown, the next exception will not be thrown. Only one at a time. We can declare multiple exception using throw keyword that can be thrown by the method. For example, main throws IO exception and SQL exception. So Java throw example, we'll just see that more throw example. Here we can see that in this particular example, let me just keep with that example. I'll copy the entire code and then explain. see this now. In this code, we can see that public static void main will start with that we are creating an object of the class exception in Java, correct? And that object is calling the check num with -3. Check num method is being called with the -3 as an argument. If the number is less than 1, there is negative number, then it will throw new arithmetic exception. So definitely -3 is less than 1, so it will throw a arithmetic exception because we are creating this object of the arithmetic exception and throwing it by using throw clause. Number is negative, cannot calculate square. This is the there is the error message that will be displayed with this exception. Because we are using this throw clause, definitely this exception will be generated. Otherwise, square of the number will be printed. That's what. But as you are given -3, then what will happen? This exception will be generated. Correct? Number is negative, cannot calculate square. So this is being printed, and this arithmetic the arithmetic exception is being generated. Yes, this is a throw keywords used. So this kind of thing programs have showed you before also. Here we are doing what? Dividation m divided by n, correct? And it's throwing that arithmetic exception. So here it is not throwing the exception implicitly, rather it is throwing and it will be throw automatically. That is, we are not using the throw clause, but it will throw anyhow. Throws here, yes. So you can see that this method public static integer divide num is taking two arguments m and n, and it is telling that it may throw arithmetic exception because it is dividing m and n. So if the number of n is 0, then it will definitely throw arithmetic exception of type what? Of type divided by 0, correct? Otherwise it will not give any exception. So you are creating an object of the class with the name obj, and we are calling obj divide number, calling this method using this object with the value what? 45 and 0, correct? Is this obj necessary? No, because it's the static. Anyhow, let it be. So divide num is being used at 45 and the 0 is provided over here. So it will divide 45 by 0, it will divide 45 to 0, so it will give a divided by 0 exception of the type arithmetic exception, correct? So it will being catch over here. Number cannot be divided by 0, and you can print this then to display that what type of exception has generated, and the rest of the code will be executed after that, because successfully you have achieved to get this thing done, get this the exception to be handled. So number cannot be divided by 0, java.lang.admin divided by 0. So this is being printed because we printed e, and rest of the code we printed e, so that's why this thing has been printed. Yes, so this is here you are not having any throws clause, right? It is automatically throwing when the value of this second argument is 0. Yes, so throw and throws example, this example I have showed you before, throwing arithmetic exception. So we are calling the method, correct, which is throws the arithmetic exception. So it should be put inside the try catch block, and this particular line will be printed, caught in main method. Yes, you can print e to see the message. Yes, now we can see about you want to see about the Java custom exceptions. So custom exception creation also you have shown over here. So we want to show with some particular example, that is how this custom we can create our own exception class. Again we'll see in the second, this example is the last example, and then we'll end up our entire discussion on exception handling. I hope that you understood each and everything, and this is the entire video is sufficient for learning all about the exception and its classes. Yes, this is the in-depth and all about data on exception handling. This video tutorial will help you to understand each and everything regarding the exceptions. Just go and don't skip the video, learn it line by line, and don't skip, just go through exactly how it is being taught to you. Then you can understand each and every bit of exception handling. You don't need to go through any other video. So class invalid age exception extends the exception class. So when you are inheriting the exception class, this particular class is definitely made for the exception class only. So in this constructor of invalid age exception, you are passing this string as an argument. So when you will create an object of the invalid age exception, you can pass a string as an argument, and this string argument is passed in the super. The super keyword will call what? It will call the super class constructor of exception. Super class is exception class, right? So exception class constructor will be called. Yes, and then that particular exceptions class constructor generates an object of the type of exception class with this particular string. That string is the error message. Now we are coming to our own class. Here we are creating an object. What's the object? From the public static void main, we are creating we are calling the method validate. We'll explain you from the public static void main. So validate method, it throws invalid age exception. So it's throwing some exception, right? So if throws some exception means you have to put it inside the try block. So if you don't put inside the try block and call this method validate, it will give an compile time error. Yes, you are giving the value 13. If the value of 13 is less than 18, yes, so it will print that, it will throw this exception, throw new invalid age exception. So invalid age exception already we have created. It's our custom exception, our only created, our own exception. It's not like arithmetic exception which has been built-in exception by Java. It's our own exception. It's our own class. It's our own definition of an exception. So this class object is being called with this particular string. So this constructor will be called, and this constructor will in turn call the exception class constructor with this particular string argument taken as the error and exception message. Age is not valid to board. So whenever this line will be throwing this exception, then what will happen? It will come to this catch. And see this invalid age exception type you are using here. This class exception type you are using here. And it will print then caught the exception occurred, and you are printing this value. This value will print what? It will print that invalid age exception and this message age is not valid to vote because it is less than 18, and the rest of the code will also execute because there is no disrupt in the Java program as the exception is properly handled by the catch block. So that will be the output. Caught the exception occurred, invalid age exception, age is not valid to vote. Yes, invalid age exception. See this is being shown over here. If you give the value more than 18, then this exception will not generate for sure. You give it 20. 20 is greater than 18, right? So this condition will not match. So this particular line will not be executed. This exception will not be thrown using the throw keyword. Rather, it will go to the else and it will print that welcome to vote. And then it will print rest of the code. So the catch block will not come because no exception is there. Welcome to vote, rest of the code. Okay. So this is all about the particular examples on Java exception handling. This is all about, you have learned each and everything regarding the exception handling. Now if you go to the further level means you are going to the intermediate and expert level on exception handling. So the basics of the exception handling is covered in this video tutorial. If you like my videos, if you like the approach of my teaching learning process over here, then please like and subscribe my channel please. And you'll get this particular PDF as a note in the description of this video. Thank you very much.